Good morning students. So 12th Maths Chapter 2 Complex Numbers. Example 2.7. Find Z inverse if Z equal to 2 plus 3i into 1 minus I. So in the question Z is given, have to find is Z inverse. Solution. So first you write the given data. Z is equal to 2 plus 3i into 1 minus I. That's equal to, multiply this term, 2 into 1, 2 minus, this minus, 2 into minus I. So 2i plus 3i into 1. So 3i minus 3i into minus I. That is minus 3i square. That's equal to 2 minus 2i plus 3i minus 3 into I square. The value is minus 1. That's equal to 2 minus 2i plus 3i minus into minus plus 3 into 1, 3 equal to 5. 2 plus 3, the value is 5. 5 minus 2i plus 3i, the value is 1. So 5 minus I is Z. Okay. So you have to find Z inverse. What is Z inverse? Z inverse is equal to 1 by Z. That's equal to 1 by 5 minus I. So you have to take the conjugate. That's equal to 1 by 5 minus I. So listen, so 2 minus 2i plus 3i plus 3. So here one second, 2 into 1, 2, 2 minus 2 into I, 2i plus 3i minus 3i square. So 2 minus 2i plus 3i minus 3i square. 2 minus 2i plus 3i minus 3 into I square, the value is minus 1. So 2 minus 2i plus 3i plus minus into minus plus. So 5, 2 plus 3, the value is 5. 2i plus 3i, the value is plus 1. That's 5 plus I. So I have to take this value as 5 plus I. Here the value is 5 plus I. So we can take the conjugate. That is conjugate of 5 plus I is 5 minus I. 5 minus I divided by 5 minus I. That's equal to 5 minus I divided by. So I have to use the formula A square minus B square formula. So 5 square minus I square. So 5, that's equal to 5 minus I divided by 5 square, the value is 25. 25 minus I square, that's equal to 5 minus I divided by 25 minus I square, the value is minus 1 equal to 5 minus I divided by 25 minus into minus, the value is plus 1. That's equal to 5 minus I divided by 26. That's equal to, so we can take this 1 by 26 outside, that 1 divided by 26 into 5 minus I. So answer equal to 1 by 26 into 5 minus I. This is Z inverse value. So you have to find what is given. Z is given, you have to find the Z inverse value. solution. 5 plus 9i plus 2 minus 4i the whole bar. Solution. So, write the following in the rectangular form. What is the rectangular form? Rectangular form means z is equal to x plus iy. So, this is the rectangular form. So, what is the question given? So, have the property, first property. So, z1 plus z2, this is the formula. z1 plus z2 the whole bar is equal to z1 bar plus z2 bar. You can use this formula in this question. So 5 plus 9i plus 2 minus 4i the whole bar is equal to, substitute this. So 5 plus 9i bar plus 2 minus 4i bar. That's equal to, so 5 plus 9i bar plus 2 minus 4i bar. So you have the formula. So is it the whole bar means take the conjugate. Okay. So you have to have the bar value here. So you have to take the conjugate here. So 5 minus 9i plus 2 plus 4i. So conjugate of 2 minus 4i is plus 4i. That's equal to 5 minus 9i plus 2 plus 4i equal to, so add this like terms. So 5 plus 2, the value is 7 minus, so minus 9, 4 is here. So we can write minus 5i. So answer equal to 7 minus 5i. So next question. Second question. If z equal to x plus iy, find the following in rectangular form. First solution. So real part of 1 by z. Solution. So now listen, what is given in the question? If z equal to x plus iy, find the following in rectangular form. This is the rectangular form. Have to find the real part of 1 by z. Have to find the real part of 1 by z. So real part of 1 by z equal to real part of 1 by z value is x plus iy. That's equal to real part of 1 by x plus iy into, have to take the conjugate. Okay. So real part of 1 by x plus iy into conjugate of x plus iy is x minus iy divided by x minus iy. That's equal to real part of x minus iy divided by, you can use the formula a square minus b square formula. So a square minus b square is iy the whole square equal to real part of x minus iy divided by x square minus y square I square. That's equal to real part of x minus iy divided by x square minus y square. So you have I square value is here. So I square value is minus 1. So minus 1. That's equal to real part of x minus iy divided by x square minus into minus plus y square. equal to real part of x by x square plus y square minus I by iy divided by x square plus y square. You have to find the real part. This is the real part and I term is the imaginary part. This is imaginary part. So what is the answer? Only have to find the real part. So the answer is x by x square plus y square. So in the question they asked the real part. So you have to find the real part. Second subdivision. Real part of I z bar. Solution. So real part of I z bar is equal to real part of I z value is x plus iy. X plus iy. Here bar is there, so you have to put the bar. That's equal to real part of I into x plus I by the whole bar, that is z bar. Have to take the conjugate. Conjugate of x plus iy. Conjugate of x plus iy is x minus iy. That's equal to real part of, have to multiply this I inside. So ix minus I square y. That's equal to real part of ix minus I square value is minus 1 into y. That's equal to real part of ix minus the minus plus y. That's equal to real part of y plus ix. Here which is the real part, this y is the real part and x is the imaginary part. So what is the answer? Answer equal to y. So in the question they asked the real part. But you have to write the real part. Third question, if z1 is equal to 2 minus I and z2 is equal to minus 4 plus 3I, find the inverse of z1, z2 and z1 divided by z2. Solution. So first z1 is given and z2 is given. You have to find the inverse of z1 into z2 and also have to find z1 divided by z2. First to write the given data. z1 is equal to 2 minus I and z2 is equal to minus 4 plus 3I. We have to find, first we have to find z1 into z2. z1 into z2 is equal to 2 minus I into minus 4 plus 3I. That's equal to 2 into minus 4 minus 8 plus 2 into 3I 6I minus into minus plus I into 4 4I minus into plus minus 3I square. That's equal to minus 8 plus 6I plus 4I minus 3 into I square value is minus 1. That's equal to minus 8 plus 6 plus 4, the value is 10. 10I minus the minus plus 3 into 1, 3. That's equal to minus 8 plus 3, the value is minus 5 plus 10i. This is Z1 into Z2. Then you have to find the inverse. Z1 into Z2, the whole bar. That is Z1 into Z2 inverse is equal to 1 by Z1 into Z2. That's equal to 1 divided by, have to write this value, minus 5 plus 10i. That's equal to, take the conjugate, 1 by minus 5 plus 10i into, so conjugate, minus 5 minus 10i. Minus 5 minus 10i divided by minus 5 minus 10i. That's equal to minus 5 minus 10i divided by, use the formula a square minus b square. So minus 5 the whole square minus 10i the whole square. That's equal to minus 5 minus 10i divided by 5 minus 5 the whole square, the value is plus 25. 25 minus 10 square, the value is 100. 100 I square. That's equal to minus 5 minus 10i divided by 25 I square minus 1. So minus into minus plus, plus 100 equal to minus 5 minus 10i divided by 125. So that's equal to minus 5 minus 10i. So we can divide separately. So minus 5 divided by 125 minus 10i divided by 125. That's equal to, cancel this term. So 2, 5, here 2, 25. So minus 1 by 25 minus 2 by 25 I. We can take 1 by 25 outside. So 1 by 25 into minus 1 minus 2i. So this is the answer for Z1 into Z2 inverse. Next we can do for Z1 divided by Z2. So Z1 divided by Z2 inverse you have to find. So inverse of Z1 divided by Z2 is 1 by Z1 divided by Z2. That's equal to Z2 divided by Z1. Okay, that's equal to Z2 value is minus 4 plus 3i divided by Z1 value is 2 minus I. So you have to take the conjugate. That's equal to minus 4 plus 3i divided by 2 minus 1 I into conjugate of 2 minus I is 2 plus I. 2 plus I divided by 2 plus I. That's equal to minus 4 plus 3i into 2 plus I divided by, use the formula, so 2 square minus I square. That's equal to, multiply these terms. So minus 4 into 2 minus 8 minus 4 into I minus 4i plus 3i into 2 plus 6i plus 3i into I plus 3i square divided by 2 square, the value is 4 minus I square value is minus 1. That's equal to minus 8 minus 4i plus 6i plus 3 into I square value is minus 1 divided by 4 plus 1. That's equal to minus 8 minus 4 4 plus 6, the value is 2. 2i minus 3 divided by 5. That's equal to minus 8 minus 3, the value is minus 11 plus 2i divided by 5. That's equal to, we can take 1 by 5 outside. So 1 by 5 into minus 11 plus 2i. This is the answer for Z1 divided by Z2. Fourth question. The complex numbers u, v and w are related by 1 by u equal to 1 by v plus 1 by w if v equal to 3 minus 4i and w equal to 4 plus 3i. Find u in rectangular form. Solution. So the complex number u, v and w are related by 1 by v, 1 by u equal to 1 by v plus 1 by w, and v and w value is given. Have to find the u value in rectangular form. Rectangular form, you know, z equal to x plus iy. First have to find the given data. First you write the given data. So v is equal to 3 minus 4i and w equal to 4 plus 3i. So 1 by u equal to 1 by v plus 1 by w. That's equal to 1 by v value is 3 minus 4i. 3 minus 4i plus 1 by w value is 4 plus 3i. So you have to take conjugate for each term. That's equal to 1 by 3 minus 4i into conjugate of 3 minus 4i is plus 3 plus 4i. 3 plus 4i divided by 3 plus 4i plus 1 by 4 plus 3i into 4. What is the conjugate? 4 plus 3i. Conjugate is 4 minus 3i. That's equal to, so 1 into 3 plus 4i, 1 into 3 plus 4i. Then use the formula a square minus b square formula. 3 square minus 4i the whole square plus 4 minus 3i divided by, use that formula, 4 square minus 3i the whole square. That's equal to 3 plus 4i divided by 3 square value is 9 minus 4 square value is 16, I square value is minus 1 plus 4 minus 3i divided by 4 square value is 16 minus 3 square 9, I square value is minus 1. That's equal to 3 plus 4i divided by 9 minus into minus plus 16 plus 4 minus 3i divided by 16 minus the minus plus 9. That's equal to 3 plus 4i 25. That's equal to, we can take 1 by 25 outside. 1 by 25 into 7 plus I. So this is the answer. 1 by 25 into 7 plus I is the answer for this question. So now, so this is the answer for 1 by u value. You have to find the u value. So 1 by u equal to 7 plus I divided by 25. So u value is, u is equal to, take the reciprocal, 25 divided by 7 plus I. Okay. So you have to take the conjugate for 7 plus I, that's equal to 25 divided by 7 plus I into 7 minus I divided by 7 minus I, that's equal to 25 into 7 minus I divided by 7 square minus I square, that's equal to 25 into 7, so now 25 into 7, 35, 14 plus 3, 17, 175 minus 25I divided by 7 square value is 49 minus I square value is minus 1, that's equal to 175 minus 25I divided by 49 plus 1, that's equal to 175 minus 25I divided by 50, that's equal to 175 divided by 50 minus 25I divided by 50. We can cancel the values. So for fifth table I am cancelling 3, 5, here 2, 7. So 2, 1. That's equal to 7 by 2 minus 1 by 2 into I. That's equal to, we can take 1 by 2 outside. So 1 by 2 into 7 minus I. This is u value. So you have to find the u value. The answer equal to 1 by 2 into 7 minus I. Take the next question. Fifth question. Prove the following properties. First one, is it is real if and only if is it equal to is it bar. So we can prove. So is it is real if and only if is it equal to is it bar. We can take two cases. Case 1. We can prove that is it is real and given is it equal to is it bar. So is it is real and given value is it equal to is it bar. We know is it equal to x plus I y and is it bar equal to x minus I y. So is it equal to is it bar is given in the question. So we can equate both the values. So x plus I y equal to x minus iy. So cancel this term, x cancel. We can take this iy in this side. So I plus iy equal to 0. So 2yi is equal to 0. So y is equal to the value is 0. So this 2i goes to the denominator, becomes 0. So y is equal to 0. Then we can substitute y equal to 0 in z. In z equal to x plus iy, because have to prove z is real value. Okay, so z, if you substitute y value as 0, you will get the real value. So z equal to x plus I into 0, that's equal to z equal to x. So x is a real value. So hence it is proved. So it is real. Okay. So in the second case, this is first case. Next we can see the second case. In the second case, you have to prove z equal to z bar. You have to prove z equal to z bar, and given z is real. So you know z equal to x plus iy and z equal to x minus iy. Z bar equal to x minus iy. So z is real since z is real. We can take for first part. Z equal to x plus iy. Here z is real. So y value is equal to 0. Z is real means y value is 0. So z equal to x. Take this as equation 1. Z bar equal to x minus iy. Here also y value is 0. That is y is equal to 0. So z minus z bar equal to x. So take this as equation 2. From 1 and 2 we can find from 1 and 2 z equation 1 and 2 z is equal to z bar. Hence it is proved. So next we move to the second subdivision. Real part of z is equal to z plus z bar divided by 2, and imaginary part of z is equal to z minus z bar divided by 2i. Solution. So listen, real part of, first I am taking this real part. Okay, real part of z is equal to z plus z bar divided by 2. First I am taking the RHS value. Okay, so you know, already you know z is equal to x plus iy and z bar is equal to x minus iy. So I am taking the RHS. Okay, RHS value. So z plus z bar divided by 2. And we have to prove the LHS value. That's equal to z value is x plus iy plus z bar value is x minus iy divided by 2. That's equal to x plus iy plus x minus iy divided by 2. So iy plus iy and x, the value is 2x divided by 2. Cancel this 2, 2. You will get x. This is the real part of z. Okay, so you have to find the real part of z. That's equal to LHS value. Okay, so RHS, real part of z equal to z plus z bar divided by 2, hence proved. Next, we have to find the imaginary part of z. Imaginary part of z is equal to z minus z bar divided by 2i. So, first we can prove the RHS value. Okay, so RHS equal to z minus z bar divided by 2i. You know z value as x plus iy minus z bar value is x minus iy divided by 2i equal to x plus iy minus, have to subtract, you have to multiply this minus inside. So minus x minus the minus plus iy divided by 2i. That's equal to this x cancelled. We'll get 2iy divided by 2i. So we can cancel 2i and 2i. We will get 1. This is the imaginary part of z. Why is the imaginary part of z? Imaginary part of z, that's equal to LHS. So imaginary part of z is equal to z minus z bar divided by 2i, hence proved. Hence proved. Sixth question. Find the least value of the positive integer n for which root 3 plus I the whole power n. First part is real, second part purely imaginary. Solution. So find the least number, least value of the positive integer n for which root 3 plus I the whole power n. You have to find the real and purely imaginary value. You have to find the n value. So first we write the given data is equal to root 3 plus I the whole power n. So first we can put n equal to 1. So is it equal to root 3 plus I the whole power 1, that's equal to root 3 plus I. This is a complex number. It's not a real part or it's not an imaginary. It's a complex number, have the both parts. First is summation, what is given, have to find the value should be purely real and the value should be purely imaginary. Okay, so we can put another number, put n equal to 2, z equal to root 3 plus I the whole square, that's equal to, use the formula a plus b the whole square formula. So root 3 the whole square plus I square plus 2 into root 3 into I. That's equal to root 3 the whole square, the value is 3. Root 3 into 3, root 3 the value is 3 minus 1. I square the value is minus 1. A square plus b square plus 2ab. That's the formula. So root 3 3 the whole square value is 3 plus I square value is minus 1. So minus 1 plus 2 root 3 I. That's equal to 3 minus 1, 2 plus 2 root 3 I. This is for n is equal to 2. It is also a complex number. Again we have to put n equal to 3. So is it equal to root 3 plus I the whole cube. That's equal to root 3 plus I the whole square into root 3 plus I. Ultimately we find root 3 plus I the whole square. So what is the value? 2 plus 2 root 3 I. 2 plus 2 root 3 I into root 3 plus I. That's equal to multiply 2 into root 3, 2 root 3 plus 2 into I, 2I plus 2 root 3 I into root 3, 2 root 3 I into root 3 plus 2 root 3 I into I, that is I square. That's equal to 2 root 3 plus 2I, 2 root 3 into root 3, the value is 3. I plus 2 root 3 into minus 1. I square value is minus 1. That's equal to 2 root 3 plus 2I plus 2 into 3, value is 6I plus into minus 2 root 3. That's equal to 2 root 3. 2 root 3 the value is cancelled. So 2I plus 6 and the value is 8I. This is purely imaginary. Have only the imaginary part. So when n equal to 3, when n equal to 3, you will get purely imaginary value. That is it value is equal to root 3 plus I the whole cube is equal to 8I. You will get this value. Again you have to find for real value. So for finding real value you have to square both the sides. So when n is equal to 3, it is purely imaginary. So squaring on both the sides. Squaring on why we are squaring both sides. If you are squaring, you will get I square value. I square value is minus 1. If you multiply means you will get the real value. That's why you are squaring on both sides. So my root 3 plus I the whole cube, the whole power 2, that's equal to 8I the whole square. So root 3 plus I the whole power 3 into 2, 6 equal to 8. 8 square value is 64 I square. That's equal to 64 into I square value is minus 1 equal to minus 64. So it is purely real value. It is real. So when n equal to 6, so for when n equal to 6, it is real. Okay, so for answer, first part real is given when n is equal to 3, n is equal to, first part real is given, so n is equal to 6, it is real. Second part, when n equal to 3, When n equal to 3, you will get the purely imaginary value. So it is purely imaginary. So this is the answer. Next question, example 2.8. Example 2.8. Show that first part 2 plus I root 3 the whole power 10 plus 2 minus I root 3 the whole power 10 is real. Solution. So you have to find this is real. Okay. So for real have the property. So Z bar. So for real Z bar is equal to Z. You have to prove Z bar is equal to Z. The 8th property I have given in the previous class. Z bar. If it is a real, then Z bar is equal to Z. So you have to prove Z bar is equal to Z. So Z equal to 2 plus I root 3 the whole power 10 plus 2 minus I root 3 the whole power 10. So you have to take the conjugate, that is Z bar equal to 2 plus I root 3 the whole power 10 plus 2 minus I root 3 the whole power 10 the whole bar. That's equal to have the property Z1 plus Z2. Have to use this formula. Z1 plus Z2 the whole bar is equal to Z1 bar plus Z2 bar. That's equal to, so 2 plus I root 3 the whole power 10 the whole bar plus 2 minus I root 3 the whole power 10 the whole bar. That's equal to 2 plus I root 3 bar the whole power 10 plus 2 minus I root 3 the whole bar the whole power 10. That's equal to, if power is there, you have to take the conjugate. So 2 plus I root 3 conjugate is 2 minus I root 3. So 2 minus I root 3 the whole power 10 plus 2 plus conjugate of 2 minus I root 3, 2 plus I root 3 the whole power 12. That's equal to, so what is the value here? So Z value already have 2 plus I root 3 the whole power 10 plus 2 minus I root 3 the whole power 10. So same term you get. So this is equal to Z. So Z bar is equal to Z. Hence it is a real. For finding real value, so Z bar is equal to Z. We can see the second subdivision. Second subdivision, 19 plus 9i divided by minus z. Okay, so first we can take the first term. Then we have to find the second term. Okay, so first 19 plus 9i divided by 5 minus 3i equal to 19 plus 9i divided by 5 minus 3i. Conjugate, you have to take the conjugate. 5 minus 3i conjugate is 5 plus 3i divided by 5 plus 3i. That's equal to 19 plus 9i into 5 plus 3i divided by, use the formula a square minus b square formula. So 5 square minus 3i the whole square. That's equal to, multiply 19 minus 19 into 5, value is 95 plus 19 into 3i, value is 57. So 27, 57 plus 57i plus 9i into 5, 45i plus 9 into 3, 27 I square divided by 5 square, value is 25 minus 3 square, value is 9 I square. That's equal to, so 95 plus 57i plus 4i plus 27 into minus 1 divided by 25 minus 9 into I square, value is minus 1. That's equal to 95 plus, so 57 plus 45, add the value, so 12 here, 102, 102i plus into minus, minus 27 divided by 25 minus the minus plus 9. That's equal to, subtract this value, 97 minus 27. So here 58, 68 plus 102i divided by, add the value 34. That's equal to 68 divided by 34 plus 102i divided by 34. That's equal to, we multiply 34 to 68. So cancel this 2. So 34, 3 12, 102. So 3. 2 plus 3i. This is for first term. Next we have to prove, next you have to find the second term. So one mistake is there. Question is here plus. Okay. Question is 8 plus I. So change this question. So plus I. So plus 8 plus I divided by 1 plus 2I into 1 minus. We have to take the conjugate. So 1 minus 2i divided by 1 minus 2i, that's equal to 8 plus I into 1 minus 2i divided by, so 1 square minus 2i the whole square. That's equal to, multiply 8 into 1, 8, then 8 into minus 2i minus 16i, then plus I into 1 plus I minus 2i square divided by 1 minus 2 square, 2i the whole square, so 4i square. That's equal to 8 minus 16i plus I minus 2 into I square, value is minus 1 divided by 1 minus 4 into I square, value is minus 1. That's equal to 8 minus 16i plus I minus into minus plus 2 divided by 1 plus 4. That's equal to 8 plus 2 the value is 10 minus 16 plus 1 value is minus 15I divided by 1 plus 4 the value is 5. That's equal to 10 divided by 5 minus 15 divided by 5I. So we can cancel this term. So 2 here 3. That's equal to 2 minus 3I. This is for this part. Okay. Now we have to subtract both the value. So for 19 plus 9I divided by 5 minus 3I, the value got is 2 plus 3I the whole power 15 minus 2 minus 3I the whole power 15. So this is Z value. That's equal to, you have to find the Z bar value. That's equal to 2 plus 3I the whole power 15 minus 2 minus 3I the whole power 15 the whole bar. That's equal to 2 plus 3I the whole power 15 the whole bar minus 2 minus 3I the whole power 15 the whole bar. That's equal to 2 plus 3I whole power 15 minus 2 minus 3I the whole bar power 15. That's equal to, you have to take the conjugate. So 2 minus 3I the whole power 15 minus 2 plus 3I the whole power 15. This is the, you got the answer this. So we can take minus outside. If you take minus outside, you will get 2 plus 3I the whole power 15 minus 2 minus 3I the whole power 15. That's equal to minus, this is the Z value minus Z. So Z bar is equal to minus Z, hence it is purely imaginary. This is purely imaginary. So next we have the homework problems. So homework, exercise 2.4, first one, second part and third part, second problem, third part and seventh problem.